a specialist for hybrid cloud at Google. And I'm going to walk you through a deep dive of the platform. So before this session, John walked through more of an overview of the different components and kind of how we arrived at Anthos. I'm going to go a little bit further back in time up front and then go really deep into the architecture, hopefully. And if you have questions throughout, just raise your hand and I'll stop and we can address the questions. So I'm not going to leave time at the end for questions, so please make sure if you do have a question, feel free to interrupt me. Looking at this set of diagrams, what immediately jumps out at you between the two pictures? Anyone? That's not a rhetorical question. I need an answer. One has a lower resolution. Yes, that is one obvious answer. What else jumps out at you? That's a bad copy-paste job.
The right-hand side is the open source spin-offs.
The right hand is, yes. This is actually the first time I haven't gotten the answer that I wanted. They are the same architecture. That's the answer I was looking for. On the left is Borg, and on the right is Kubernetes. Can anyone tell me what Borg is? It's Google's first version of Kubernetes. It's actually what we still run on today. So Borg has been in production for us. It's running our entire infrastructure, and it's been that way for the last 15 plus years. We've been running on containers since right around 2003, 2004. And ever since we invested heavily in containers, we designed this massive monolithic container orchestration platform called the Borg. And we called it Borg because, especially for those of you Star Trek fans out there, we called it that because anytime a deployment dies, it gets spun back up. It self-heals, much like the Borg. Now, today, we use Borg to spin up around 4 billion containers every single week. I just saw a tweet from VMware, actually, where they're showcasing their infrastructure, where they spin up about 1-point-something million VMs and another, 1-point-something containers. And I was like, well, we're at 4 billion. But 15 years, we've been orchestrating containers in our infrastructure. Anything that you use at Google today, whether it's search, maps, Gmail, YouTube, you name it. Think of a Google service, inclusive of Google Cloud. When you spin up a virtual machine in Google Cloud, it's running in a container. I don't know why it's doing that. Same problem, right? Is it the way I'm standing? Is it? Okay. But what we did was around a little over 5 years ago, and actually Kubernetes just turned 5 a few days ago, we internally went to the head of our technical infrastructure team and said, hey, you know what? We want to take the best practices of what we've learned across over a decade of orchestrating containers at scale, and we want to open source it. And this is our secret sauce. This is how we run our business. This is what differentiates us from every other organization and every other company out there. And it's important to remember that Google is an enterprise business. We have consumer products that we sell. And that we have 6 billion users of all of our services, whether they're free or not, whether it's G Suite or any of the other consumer products that you use, whether it's, as I mentioned, search and maps and things like that. So what we ended up doing was we took all of our lessons learned, all of our best practices, and we packaged it up in a thing called Kubernetes, and we open sourced it to the world. And this ended up becoming our this is how we conveyed how Google runs as far as application automation goes, right? Application lifecycle automation. And I'm scoping it to that because part of Anthos is the completion of what Kubernetes started. Kubernetes, the way it began and the way it's evolved over the years as an open source project is really for app level lifecycle automation and management. It's not great for everything else that the enterprise is concerned with. And so Anthos is meant to be a conveyance from Google as to how we manage things in the enterprise beyond just Kubernetes. If you were here for the last session, I answered a question around, how do I get started on Anthos? And I'd mentioned in my answer that we're trying to commoditize Kubernetes. Whether it's GKE on-prem, or some other distribution, we're effectively trying to commoditize that API. We don't want to make Kubernetes such a first-class citizen in an infrastructure where you have to spend all of your time managing it. We want to make the management of Kubernetes, wherever it is, exceptionally easy. And this gets into enterprise adoption. Right? For the last 4 or 5 years, I've been running around with Kubernetes for the last 4.5 years. And everyone I've ever spoken to around Kubernetes has dealt with, well, we got to upgrade this thing. And the last time we tried an upgrade, everything broke. It's always a significant maintenance window. Something breaks. There's always a lot of moving parts. Upgrades have become onerous. And now vendors are just starting to address this. And this is something that we have been addressing in GKE for the last 4 years, where upgrades are a non-event. There should be no trauma associated with an upgrade event. So that's effectively where Kubernetes came from, right? We created it, we open sourced it, and we still operate on its principles. So Borg hasn't gone anywhere. Kubernetes now, 5 years later, after we open sourced it, is now the new operating system of the cloud. The way we have seen Linux grow and become ubiquitous across the board as a general purpose operating system, we're seeing the same thing happen for deployments in the cloud, for cloud native applications. And can anyone tell me, this is a bit of a challenge in the room, and maybe this is short-sighted of me, I'm probably shooting myself in the foot, but can anyone tell me, name a vendor or a cloud provider that does not support Kubernetes in some form or fashion? Can anyone name a company? Even DigitalOcean supports it. They have their own managed Kubernetes offering. Yeah, they just GA'd it like 2 weeks ago, actually. Yeah, it's a nice experience. Not as nice as GKE, though. Even Oracle, right? Everyone supports Kubernetes. This is just a subset of all of the distributions of Kubernetes that are out there. Everyone is packaging up the open source bits and delivering it to the world. They're rebranding it, they're platforming it, and they're providing enterprise-grade support for it, which really is just a throat to choke, a phone number to call, a way for you to submit a ticket and yell at support because something's not working with their specific distribution, right? That's enterprise support, quote unquote. But this is how many distributions there are. And this is indicative of not just the success of Kubernetes, but my statement earlier that I made a minute ago around Kubernetes being the new OS. Look at how many Linux distributions there are. How many flavors of that? It's the same concept. It's the same thing that's happening. The way Linux obfuscated away underlying infrastructure, in some regards, we're seeing Kubernetes do the same exact thing. The providers no longer really necessarily matter as much, right? I don't have to concern myself with the underlying infrastructure with Kubernetes as much as I used to. What we're doing with Anthos is we're trying to commoditize the provider, including ourselves. It's a bit antithetical for me coming from Google Cloud to say we're trying to commoditize ourselves, but we're also trying to commoditize Azure and AWS. The provider shouldn't matter. A lot of organizations worry about lock-in. Some organizations will consider cloud to be the ultimate form of lock-in. And so what we're trying to convey with Anthos is the fact that you shouldn't have to be locked into a single provider or vendor or even a single platform, right? We do differentiate in those in between those flavors of lock-in. So what Anthos is, and I'm just going to do a quick overview because John did a really good job earlier of going through the high level. We're looking at Anthos first and foremost as effectively a hybrid application monetization platform, right? Upfront marketing term. We're providing through Google Cloud a control plane of control planes. From Google Cloud, you have a multi-cluster management capability that allows you to manage environments, consistent environments across providers. Now, whether that's in your data center, whether that's in AWS, whether that's in Azure or in Google Cloud, that's entirely up to you where you want to live, but the way you manage it, the way you configure these environments should be consistent and from a central point. And so we're trying to, through Anthos, provide a multi-cluster management capability that, frankly, for us has existed for over 4 years. With GKE, that has been GA for 4 years now, or almost 4 years now, we're shy of it by like a month or two, we've had multi-cluster management capabilities. We're simply extending that outside of Google Cloud at this point with Anthos. Now, the design principles of Anthos are primarily driven by the personas that we notice in every organization that we talk to and that we work with. They are usually divided up by these three personas: application owners or development teams, if you want to call them that, platform operators or infrastructure and operations teams, if you want to call them that, and security administrative teams, and tangentially also networking teams. Now, if you'll notice, underneath each of these personas, they have different priorities. All of these priorities, these different personas, are all working towards the same goal. They are working towards supporting the business, the mission, whatever it is. But sometimes these priorities conflict. Development teams, for example, want to introduce new capabilities. They want to introduce change, new tool sets, new technologies, innovations to push the business forward. Infrastructure teams hate this, right? They don't like change. They like to mitigate risk, and they see change as risk. And oftentimes these types of activities conflict with one another. And this historically has lent itself to this paradigm where developers simply throw something over the wall and say, hey, it worked on my machine, and then something breaks in production, and then I'm stuck on a Friday afternoon trying to figure out why production just broke and how we're going to roll back. And that's always a non-repeatable scenario. So the building blocks that we're using in Anthos that are going to map to those personas are three primarily. The first and foremost, obviously, is Kubernetes. And I'm not going to beat a dead horse around why that's important. But the second one is Istio, which is an open source framework that provides a service mesh that's idiomatic to Kubernetes. It sits on top of Kubernetes. Where Kubernetes abstracts away the underlying infrastructure, Istio abstracts away the underlying network concerns, network security concerns. And then Knative is something that we open sourced last summer. And this abstracts away the developer experience as it pertains to serverless patterns wherever you might be. And this is important. This is an important point for development teams. This isn't to say that Knative or Kubernetes is going to reach into your local environment, really. This isn't even to say that well, I don't need the picture right now. I'll fix it in a second. This isn't even to say that you need to know how to spell Kubernetes as a developer. This is to say that I, as a developer, need to have certain interaction patterns or serverless patterns for me to be able to work more efficiently, more effectively. Why do developers go to AWS Lambda? Why do developers go to Google Cloud Functions or Azure Functions? Because they want to iteratively develop and deploy and develop very quickly at an increased pace without having to worry about environmentals, without having to worry about the infrastructure, without having to spin things up and then back down or being responsible for any of that. However, for me to go to AWS Lambda or Google Cloud Functions or Azure Functions, I have to wholesale buy into that ecosystem to be able to leverage it effectively. What we did with Knative is we introduced an open source framework that presents the building blocks to build out, to construct a serverless platform on top of Kubernetes. So now, that serverless platform, the experiences that my developers have are now just as portable as the workloads that I'm deploying. So Anthos, in summary, in aggregate, through all of these open source technologies, is all about consistency across providers. It's also about consistency in skill sets, consistency in processes. It's consistency and portability across the board, right? That's the goal. That's the vision for Anthos, and that's how we're designing it. And that's true, and I'm going to go back one slide, that's true for each of these personas. The experiences for developers, the experiences for platform operators, and the experiences for security teams should be the same. I shouldn't have to have separate concerns or considerations because I'm deploying to AWS. I shouldn't have separate concerns or considerations because now I'm deploying to on-prem. For me to have a hybrid cloud or multi-cloud strategy, I need to be consistent across those environments. If I can't have that consistency, my strategy is going to fail. And we see this all the time. Across verticals, across industries, everyone's taught, yes, question.
Sorry,
No, I asked for it.
Okay.
You're good.
So you mentioned cross-cloud compatibility,
Mm-hmm.
and I see you mentioned cloud and on-prem, but what about across form factors? So, for example, you also support like the micro K8 form factor, like deployment on edge and things like this?
I don't know if we'll support microcates and other form factors of Kubernetes.
Okay.
This goes back to the different flavors of Kubernetes, different distributions of Kubernetes. We are doubling down on the Kubernetes API. I'll say that, right? If you bring the Kubernetes API to us, it's likely something that we can work with through Anthos. Now, if it's not GKE, then there will probably be a degradation in capabilities because GKE obviously for us is a first-class citizen with respect to Anthos because it gets into how clusters are managed. Now, if you bring like an OpenShift or a K3S or a microK8s in, sure, you can view your cluster and your workloads and things like that, but you might not be able to manage it as effectively as you might be able to with GKE and GKE on-prem. The reason we're doubling down on GKE and GKE on-prem is because we've spent the last 4 or 5 years mastering cluster management, where I can click a button and execute an upgrade, go get a cup of coffee and come back, and my cluster's been upgraded. And it's a non-event for me. We can't affect that same type of capability with distributions that we don't own. And it's just a function of that. It's just a function of ownership. And we are very careful about making sure that we separate out our cluster management API and the Kubernetes API. And that's actually important. Going back to the building block slide, these three different technologies, these open source technologies, all three of these have come from Google. Every single one. And every single one of these has one of the largest communities surrounding it, especially Kubernetes. We're talking about over 450 person years of work in Kubernetes, 800 different vendors, 25,000 different contributors, right? So this is a monumental project. Istio is following suit as the service mesh of choice. There are other service meshes, but none nearly as popular as Istio. It is how we are conveying to the world how we deploy a service and manage that service and secure that service. Right? Internally to Google, when we deploy a service, we deploy that service in our trusted network as though we're deploying it out on the public internet, and that's how we secure it. Those mechanisms are finding their way into Istio. We drive the Kubernetes project. We own the Kubernetes API in the open source community. We drive its strategy, and the same thing is true for Istio as well as for Knative. And this is across the personas that care about these projects. So for platform operators with Kubernetes, for networking and security admins with Istio, and for developers with Knative. Now, this is a, yes?
Sorry, would you go back to...
Stop apologizing. Yeah, what's that?
Would you go back to the previous slide?
Yes, this one here?
So these three projects or products, Knative, Kubernetes, they're all open source projects.
Yes.
Communities around them.
Yes.
Is Anthos like a distribution of
yes.
these open source projects?
Yes, we're packaging up these APIs and effectively just providing support and calling it Anthos.
And does it have some sort of like layer on top, software layer on top that is proprietary, or is anything that you build on top is also...
The proprietary aspect is coming. I'll talk about that. And I'll talk about the separation between what we provide in terms of value add versus the open source APIs. I will say, to address that up front, we separate out management APIs versus implementation APIs. I'm going to call these three here the implementation APIs. We bring proprietary management APIs alongside this because that's our value add as Google and Google Cloud. All of your implementations will go against the open source APIs. We don't take an opinion on these APIs because they're already our opinion because we invented them, right? So there's no abstraction, there's no additional layer there. What we do bring in parallel to this is a management API set for cluster management, for services management, for making sure that your development interaction patterns are usable. So from an enterprise adoption standpoint, we do bring a proprietary set of APIs that run in parallel to these open source technologies. Now, if you wanted to walk away from Google and Google Cloud, if you wanted to walk away from Anthos, what you lose are those management capabilities, but you could literally take all of your implementations, your declarative manifests, so whatever you're using for Kubernetes, your manifest for Istio, your manifest for Knative, and just go to a different distribution that supports those APIs, which, by the way, is literally everyone. Now, the stack itself, there are two components that live in Google Cloud. The first is Hub, and the second one is Service Mesh, the Cloud Service Mesh. The Hub is our traditional multi-cluster management single pane of glass, which is the Google Kubernetes engine page that exists today, and we're going to continue iterating on that as far as multi-cluster management goes. We've been doing it for a long time. We're just simply extending it out to Anthos clusters that live outside of Google Cloud. Service Mesh is new, and that is our instantiation of adopting Istio in the enterprise. Istio is hard, by the way, just like Kubernetes is hard. Both of them have their own control planes. They're highly complex, lots of moving parts. Our effort with CSM, and again, to the point I made to answer your question earlier, is about how we adopt this in the enterprise. We are managing the control plane for Istio in the sense of allowing you to simply use policies to be able to manage your services, to secure your services, so that you're not hacking away at YAML all the time. Rather, you're actually looking at what's happening and you're able to take actions on what's happening at a more abstracted level, right? So from a management standpoint, it's much easier to use, much easier to adopt, but the underlying implementation of what's happening is still against the open source API, which is Istio. Now, looking below on the blue, you have GKE in Google Cloud and GKE on-prem outside of Google Cloud. These are not two separate distributions, they're the same bits. There's a lag between GKE on-prem and GKE because bringing something outside of Google Cloud involves orchestrating certain machinery that has to be implemented for you to have the same cluster management experiences outside of Google Cloud that you have within Google Cloud. GKE on-prem gives you similar capabilities around upgrades, around just general cluster management. If you're familiar with GKE, you'll likely get what I'm talking about. If not, then bother me after, or not, you won't bother me, but just ping me afterwards, and I can give you a quick rundown of GKE. Well, what's living outside of Google Cloud on an Anthos cluster, whether it's on-prem or an AWS or an Azure, is GKE on-prem. That's the Kubernetes distribution. Sitting on top of that is an Istio control plane, and then sitting alongside that is our configuration management mechanism. Now, as you'll notice, Hub is going to help you manage and orchestrate the GKE components, okay, where you can see all of your clusters, you can see the workloads on the nodes, you can see the resource utilization, you can see all sorts of things from that multi-cluster management plane. CSM, and so the Istio implementations on your clusters are going to be managed through service mesh. Config management is an interesting piece because that's going to be a GitOps mechanism that we're introducing around configuration management for your multiple clusters. And I'll get into that in a second. So let's talk about the platform experience specifically with GKE on-prem. The installation of GKE on-prem is interactive. Basically, you're going to run an interactive interview session where you're going to be asked a number of questions, and based on your answers, we generate a configuration template, which then we use to instantiate the architecture or the installation. And looking at what that installation looks like, we have a concept called Kubeception. Who here has seen Inception, the movie with Leonardo DiCaprio? Yeah, it's dreams within a dream, right? A dream within a dream. So we're actually deploying Kubernetes within Kubernetes, which is why we call it Kubeception. This is how we're able to execute different cluster management capabilities, similar to what you experience in Google Cloud with GKE, things like cluster provisioning and cluster upgrades. No, I really need the screen right now. All right. So we have what's called an admin control plane. Okay, this is effectively an administrative master. That master then deploys a pod which acts as a user cluster master. Okay, so a master is deploying another master. This master is the master of the cluster that you will deploy your workloads to. Does that make sense to everyone? Okay. So I'm able to tell my administrative control plane, hey, I want a cluster. I want 3 nodes in that cluster so that I can deploy my workloads across those 3 nodes. And so GKE on-prem will say, okay, thanks for that information. Let me go provision that cluster for you. I'll do the same thing if I want to upgrade this cluster as well. Hey, I want to upgrade this specific cluster. And then GKE on-prem will say, okay, great. I'll go ahead and do a rolling upgrade of both the masters for your user cluster as well as the nodes in your user cluster. By the way, GKE on-prem, I want to now provision another cluster. Okay, that's fine. I'll provision another cluster for you. All of this is automated. It's all programmatic. I type in a command, I hit enter, and I get what I want. This is the experience that we have in GKE in Google Cloud. This is the experience that we have on-premise today with GKE on-prem. And then at that point, it's simply a matter of using kubectl or whatever other tools you want to use to be able to deploy your workloads to the nodes as part of those user clusters. We're trying to get after a paradigm where clusters are now just as ephemeral as the workloads that are deployed, that you're deploying. So for example, in Kubernetes, when you deploy something, if something dies, it comes right back up. If you lose your entire deployment, you have declarative manifests, a deployment typically, that allows you to reinstantiate that. The same thing should be true for your clusters as well. Again, we're trying to commoditize the management of Kubernetes as much as possible, or rather simplify it. Your clusters should not be these super fragile or brittle pets that you have to take care of over time. They should be things that come up and are able to be taken down effectively and efficiently. Now, if you want to treat them as pets, go for it. But you should still have that capability to treat your clusters as ephemerally as you want to, especially if you have varying levels of multi-tenancy within your organization. That's important. And how you want to be able to provision and provide your Kubernetes environments to your teams, to maybe individuals even, that's important as well. You should not be constrained by the fact that, oh, well, our teams are only able to manage a couple of clusters at a time because it's hard to manage Kubernetes. That has to go away. And that's what we're trying to force out of the Kubernetes industry through GKE and GKE on-prem. We've already done that with GKE. We've got customers today that are running Black Friday operations on hundreds and hundreds of clusters, and they're able to manage it effectively with the same team that would have otherwise had to manage 2 or 3 different Kubernetes clusters if they were rolling their own. Now, as far as networking goes for, all right. As far as networking goes, we're instantiating by default the Anthos clusters through GKE on-prem are in, wow, that's weird, are in island mode. Can you still see?
Try this one, perhaps.
Okay.
That worked last time.
Alrighty. Yeah. Let's see if this one works. Okay. So networking is island mode. What island mode is basically your pod ranges and your service ranges are internal to the cluster only. This is a typical setup for Kubernetes, and this is consistent in GKE on-prem. Per user cluster, we're limiting it right now to 50 nodes. We've yet to work with a customer or an organization that needs more than that, especially since you can actually provision multiple user clusters, each with 50 nodes. So I think the upper limit right now is 10 user clusters, 50 nodes per, so that's 500 nodes for a single administrative admin control plane. And then you can go ahead and provision a new admin control plane, and then you have another 500 possible worker nodes at your disposal at that point. So we feel that that's a pretty good number for right now. We don't really see a need. We haven't seen a demand for larger than that. Right now, for our MVP, over the last 10 months, we did an integration with F5. As of Monday, you'll be able to bring your own load balancer. We are also going to be packaging our own open source load balancer as part of Anthos as well. So you have really the option to do whatever you want at the load balancer level. Network policy is through Calico. So if you really like Kubernetes network policies, and I do recommend them in conjunction with Istio policies, it's Calico. And there's really nothing else that we use Calico for. We just needed some sort of performant SDN that implements the network policy API in Kubernetes. And as expected, as with any other Kubernetes installation, for the most part, when traffic leaves from a pod, it nats the IP address of the node. And you can also use node port type services if you want to not go through a load balancer necessarily, but just go through a service directly. You have that capability as well. Any questions around networking? No questions around networking? This is like the hard, okay. It's Friday. I don't blame you. This is a screenshot of the Kubernetes engine page as it exists today. With GKE on-prem clusters, you'll get notified if there's an upgrade that's available. And you can, again, this is a top-down type of visibility where you can view your clusters. You can click into a cluster, view your nodes, and click into a single node, view the pods that are deployed on that node, the resource utilization of each of those deployments. You can also view different network services that are deployed, the types of services that they are, whether they're cluster IP, node port. You can see the health, the logs, events, YAML manifests, everything from this single, effectively, pane of glass, as much as I dislike that term. So this is your multi-cluster management plane. This is something that other vendors are kind of looking at approaching, but the reason we're going through Google Cloud Console to provide this capability is because this is something that is more mature than anything else that's out there. This is a 4-year-old single pane of glass that has been purpose-built for multi-cluster management for Kubernetes and nothing else. And so we're re-leveraging this for Anthos clusters sitting outside of Google Cloud as well. To do that, we've designed a proxy, or I'll call it an agent. It is a normal Kubernetes deployment that Google has created. So we will provide it as part of Anthos. We support it. And we will also give the entire security posture of this deployment over to you, the organization that actually runs this agent on your cluster. This agent reaches out. Google Cloud never reaches into the cluster. We don't instantiate a connection. You have to allow the traffic to leave your data center or to leave AWS, wherever Anthos is installed, for that connection to make it out back to Google Cloud. And that connection back to Google Cloud is to your specific project in Google Cloud. It's not to us, right? It's to your specific project that only you have access to. The security posture around this is, there's a whole white paper around it. There's a bunch of documentation around the measures that we've taken on our side, on the engineering side, to secure the communication and the data that's coming out. It's all metadata, non-identifiable. But the bottom line being is that this is not a black box. Both the agent and the connectivities, the data transfer that's being transferred, all of it is logged out, and it's auditable. And so this is not something that we designed where we're introducing any sort of risk or an additional threat vector. Rather, this is something that we're shipping, we're supporting, we're securing, and we're giving that control of that security over to the organization that's running this thing. We did this for the purposes of multi-cloud and hybrid cloud management. If you have clusters in AWS and on-prem and in Azure and in Google Cloud, you have to have an effective way to manage those clusters, to view them, to observe them, to upgrade them, you name it. Frankly, in a hybrid multi-cloud world, there's no other way to do that. And we felt that our infrastructure was secure enough and that we could build and create an agent that's secure enough and design it in such a way that it meets security standards and compliance standards for organizations to be able to adopt effectively. Otherwise, what you're getting is a multi-cluster management single pane of glass that's really read-only, effectively. You're not able to do much of anything else. As far as configuration goes, so I talk about clusters that live in various parts of your IT environment. So let's say I've got 15 clusters in AWS, and I've got another 10 clusters in Azure, I've got half a dozen in GCP, and I've got 20 clusters on-prem. That's a lot of clusters. Even if it's half that, it's still a lot of clusters. Because GKE and GKE on-prem are so easy to provision, literally, I type a command, I hit enter, and I get a cluster as I need it. Now, how do I efficiently manage this sprawl of clusters? Cluster sprawl is a problem that we at Google Cloud have specifically seen with our customers because of how easy it is to provision and manage and use Kubernetes. Again, as I mentioned, we have customers that have hundreds and hundreds and hundreds of clusters. How do they manage? How are we going to allow them to manage all of these things, especially across now providers? So we have introduced what's called Anthos Configuration Management, which is simply a controller that lives on the cluster that references back to a single source of truth, which happens to be a Git repository. In that Git repository, I can have a canonical definition for what I want my cluster configuration to look like. So this is very much respecting the hierarchical nature of Kubernetes, where I can have namespaces, I can have quotas, I can have an entire RBAC model, I can have network policies, I can have Istio policy configurations, everything. Not just the Kubernetes API, but the Istio API. If I want to introduce other CRDs or operators, I can incorporate those as well. But anything and everything that exists as an API object in my environments, no matter what provider they're on, I can now manage their configuration in real time through a Git repository. That is to say that now I can push a change. For example, if I want to increase the quota for my shipping backend namespace, I can make that change, push that change into my repository, into a release branch, and as soon as that gets pushed into the repository, all of the clusters that are referencing that branch will immediately update themselves and reflect that change. Instead of me having to go into each and every cluster environment and making that change myself and doing kubectl apply-f dot, right? This is key because you want to remove human beings from this activity of updating configuration. Not only that, you also want to be able to leverage the same practices that developers have been leveraging for many, many years using tools like GitHub and GitLab, where if I want to make a change to code, I need to be able to submit a PR, which then gets reviewed, and upon successful review by robots and humans, then it gets merged into a release branch, and then we can deploy it. That is a best practice that developers have been doing for the longest time. And that is something that we're trying to shift left to operations and security teams, where now ops teams, security teams, networking teams can declare the posture that they want their environments to have. And now you can use Git mechanisms at your disposal. So I can have a dev branch, a test branch, a production branch, and all of these branches can have their own unique configuration where my AWS clusters, let's say I've got 15 of them, as I mentioned, that's going to be my dev environment, and those clusters are going to reference the dev branch. And that dev configuration is going to be my single source of truth. If for whatever reason there's a hiccup in my organization and someone comes in through a side channel and goes directly to a cluster somehow and gains access and changes the configuration of that cluster will immediately revert back to the source of truth and update itself repeatedly to make sure that it aligns with that source of truth. Okay, so this is an active capability. This is not just a human being having to go through this process. It's if there's a side channel issue, if there's any side channeling whatsoever, the cluster will rectify itself back to what is in the Git repository. And so we're trying to bring this best practice, and now we can start thinking about things like continuous ATOs for environments, right? We can start thinking about mapping Kubernetes and Istio and Knative and all these different types of manifests to compliance, right? We can codify all of that into a Git repository, and that's our single source of truth, and it's an administrative repository that only specific individuals on specific teams have access to. But this is what we're talking about. This is the next step in configuration as code, for example, or infrastructure as code. Now, application SRE, this is actually a thing, right? Site reliability engineering is something that Google has pioneered. It is our implementation of DevOps before DevOps was a thing. We feel that SRE and DevOps are not two separate things. DevOps is a template. SRE is our implementation of that template. And we apply this to applications. It's all about keeping applications safe and keeping them alive. And this is where the service mesh comes into play. So what does the service mesh do? For those of you that were in the previous session, this is a bit of a review, but it gives you three unique things. Uniform observability across your environments. Right? Remember, we're talking about environments that can live in different providers. Operational agility, the ability to be able to pivot and change in terms of what traffic is going where, what services are locked off, what services are opened up, who's connecting to what, who's talking to who, over what port, is that port secure, et cetera, and so on and so forth. And being able to change that on a dime, right, through declarative manifests that are in my single source of truth repository. So there's a feedback loop here as well. And then I need to be able to do all of this through declarative policies. Again, there's a lot of tie-ins between this and configuration management. They're not two distinct capabilities that stand apart. There's a feedback loop that has to be established, and that's why I talked about this in the context of application SRE. It's a cultural practice that has to be established around your services management. It's not just the technologies by themselves. You actually have to promote your people skills and your processes towards this, right? This is just an enabling technology, but this is absolutely going to be a function of your culture. Rather, your culture will be a function of this, sorry. So uniform observability, as I mentioned, I need to be able to see what's happening, why it's happening, and how it's happening in real time at all times. What we're doing in CSM, if you remember, I mentioned that CSM is one of two components that are living in Google Cloud as a managed capability as part of Anthos. One of them is Hub, which is our multi-cluster management control plane. The second one is CSM. What we're doing is you're installing Istio in all of your Kubernetes, your Anthos clusters, in every provider that you want to live in. We're using the mixer component in Istio to siphon out all of the information, all of the telemetry data, and we're presenting it to you in the CSM interface. Nothing is actually running in Google Cloud that you care about, but you're being presented with all of that information that you really do care about in Google Cloud through CSM, through GKE Hub. Okay, so that's an important distinction here. You don't have to run anything in Google Cloud whatsoever. Nothing. All you're being presented with in Google Cloud is information about your deployment topology everywhere else. So you get things like topology graphs, you get things like requests per second. You're able to now also set things like SLAs, right? We're giving you the ability through CSM to be able to set SLAs and SLOs, where you can quantifiably measure the performance of your services. It's not just a matter of establishing a health check against a service. Now you can set a metric and say, hey, I need to have an SLA of 99% based on this health check or this other metric. And if I'm going below that, I need to be alerted, and I need to be able to be given a recommendation, and I need to be able to take an action. That's what SRE is. All of that. All of the above. It starts with observability, but it's also about proactivity, right? Being proactive about what you're observing. And so you can allocate error budgets, you can allocate all sorts of things. Through this, you can now start establishing processes to establish an SRE practice within the organization, or a DevOps practice, or whatever you want to call it at the end of the day. Every organization, every customer that I've ever talked to over the last 4.5 years around this Kubernetes ecosystem has struggled in implementing DevOps. In many cases, it's, oh, well, if we adopt Kubernetes, we'll automatically get DevOps. That's not the case. DevOps is a culture, but you need the technologies to be able to enable that. As I mentioned, operational agility, you need to be able to also make sure that you can direct traffic, that you can secure traffic, that you can implement circuit breaking. You need to be able to do things at runtime without having to bring everything down, right? You need to be able to touch things without fear of, if I touch this, everything else is going to get hosed. You need to be able to declaratively state, I need 5% of traffic to go to this Canary deployment like right now. Push that into your Git repository and watch that change happen. And you should be able to target specific cluster environments for that change. Yeah, so I'm going to skip over that. So that's Cloud Service Mesh in a nutshell. That's the icon for it. But what you're getting, metrics, logging, tracing, the establishment of SLOs and SLAs that you can act upon. The other cool thing about Service Mesh, really the cool thing about Istio is that your development teams no longer have to worry about authentication, authorization, or encryption. Today, development teams are very much handling that. For my application, how are we handling encryption? We're probably terminating encryption in our app. We're having to authenticate and authorize in the app. Ladies and gentlemen, security concerns like that are administrative concerns. They are not developer concerns. It is literally like antithetical to security, like good security hygiene, to allow development teams to be responsible for things like that. And that's exactly why we have leaks and breaches and issues at the app layer where people are just going in and siphoning data out. Because developers, again, just speaking from my own experience, we're not trained in college and in graduate school to handle TLS encryption, to handle all of these security concerns in a best practices way. This is stuff that we learn on the job once we get the job. These concerns have to be abstracted away, and you have to allow your network administrators, your security teams to be able to manage all of that consistently, and that's what Istio is bringing to the table. So Istio is hard, right, I get it, but our aim and our vision with CSM is to make that much easier to do. By decoupling authentication, authorization, and general network security issues, by removing that from the development teams and making it abstracted, right, where you can manage it through manifest, just like you manage things in Kubernetes through manifest. You can declare how you want your network topology to look like. You can declare how your services are managed, maintained, and secured. All right, so there's absolutely a shift that has to happen for us to improve organizationally, our security posture and how we handle these things, how we handle these concerns. And so there's a significant amount of value in a service mesh, and this is what the vision is for Istio and how we're surfacing it through CSM. Yes? I think a lot of the practices that can be established on top of Istio, given Istio's capabilities, are the same things that we do internally with our SRE practice. We don't use Istio specifically internally because a lot of our Google has technical debt too, right? Borg is actually part of that technical debt. It's very good technical debt, but we have our own SDN, we have our own policies and ACLs and things like that that we use internally. But again, all those lessons learned are making their way into our implementation in Istio. And so it gives organizations a chance and an opportunity to effectively run like Google, right? For years, and this is the last point I'll make, for years, everyone's been saying Kubernetes is how you run like Google. The correction there is Kubernetes is how you kind of 50% run like Google. The other 50% is in Istio and in Knative because you have to address all of the other enterprise concerns. and being able to decouple considerations and delineate between what people care about and what they're able to operate on top of. So security and networking teams should absolutely have control over Istio. Developers should not have to worry about, hey, how am I going to handle encryption and authentication and authorization? That should be absolutely transparent to development teams. I'm not going to belabor the point on Knative. I already went through that earlier. But bottom line is, you get the building blocks for creating a serverless platform that makes it so that you're not locked into like a Lambda or a Google Cloud Functions or an Azure Functions. You actually get all of those serverless capabilities and patterns for your development teams, and you can take that with you wherever Anthos is or wherever Kubernetes is. Okay? So you can literally build an in-house FAS platform, for example. You can have your own Lambda, but it's customized for you. And guess what? You can, again, instantiate this in Amazon, in Azure, in Google Cloud, on-prem, wherever Kubernetes is. That's why we call it Knative. It is idiomatic to Kubernetes. It's native to Kubernetes. So it's just as portable. It's all about consistency and the experiences. Platform, network, security, developers, right? All of it should be portable, not just the containerized workloads themselves. And so, of course, we are surfacing Knative through a service called Cloud Run. And Cloud Run will run in Google Cloud. It'll run in GKE in Google Cloud, and it'll also run in Anthos outside of Google Cloud. I think that's all I've got. What's that?
It'll run in GKE on-prem.
Yes, it'll run on GKE on-prem. That's roadmap, by the way, folks. Yeah. I think the computer just froze. I can't advance slides, but that's all I had. Are there any questions? I know we're at time. Okay, thank you. Have a good weekend.